Hey guys, PB here from the Home Automation project. Today we are going to talk about LED strips and how to set up your addressable LEDs in your smart home. So addressable LEDs are also known as digital LEDs, and I'll show you an example of these LEDs here. So this is an example of an addressable LED, and as you can see there are these chips next to the LEDs, which is called ICs or independent controllers. We can program these chips to control these LEDs individually, and we can set their individual colors, or we can set patterns and control the patterns on each of these LEDs separately using a third-party software called WLED, which is an open source software. And this software is also natively integrates with Home Assistant, so we can control the LED functions from within Home Assistant. I'm going to show you how in this video. Before that, let's have a quick look at some of the common types of LEDs and what is the difference. So as an example, this is one of the most common type of LED that we get, and this is called an analog LED. So in these kind of LEDs, you can you can program only one color for the entire LED. You can do patterns, but it's very limited, and you can only do certain color. So you can only set all the LEDs to one color. And if you see this one here says 12 volts, so an RGB. So this is an example. If you see the inputs, so you have got RGB and ground, so there are 4 inputs to this. You get another variety of this which has 5 inputs like this one. So this has got an extra RGBW input, and if you look at this one, for this you can set these there are these extra white LEDs which helps you to achieve a better spectrum of white. And the way to control these LEDs is generally these come with these controllers for the analog LEDs. These are either 12 volt or 24. These operate generally from 12 to 24 volts, and the input is this 4-pin or 5-pin LED, which and they also come with this kind of basic remote, and you can do one or multiple LEDs with this one controller, and you can plug in the power input which is through this. And there is you can use some kind of smart plug to control this if you want some more automation. Another version of these LEDs are these cob based LED, or as they called. This is also a 12 volt LED, and this is also an analog one, but it gives a better diffusion of light. Basically you don't see those annoying dots when you use this kind of version. This is very common for under cabinet lighting and kitchen lighting, and these are simple on off kind of controllable LEDs. You could use a smart controller like this one I have here. This is the Zigbee LED controller, and I can change the time and the color. If the LED strip supports color, you could change the color also with this from your Home Assistant instance by pairing with Zigbee. And then you have these addressable LEDs, and in the addressable LEDs also you can get multiple versions. So this version I have here is also an example of an addressable LED. You can see the chips here and here. And these LEDs, this is a cob version of an addressable LED. The general input for these LEDs that you get these RGB input. So the white here is your so the general input that you get for these LEDs is this 3 cable plus these 2 extra ones for power injection. So the 3 ones, there's this red is the power, white is the ground, and green is your data cable. Now this data cable is the one which you can use to program these independent controllers or ICs, and we're going to connect this data cable to our ESP32, and I will show you how we program how we can program this for various routines, functions and colors. I'm going to also use these 2 extra power injections. So depending on the length of your LED, you might need some extra power, and for each of these addressable LED there are certain subtypes of this addressable LED. For example, the one I have here is called 2811, WS2811. you have got WS2812B, and you have got WS2815, etc, etc, and there are some more versions, but these are the most common ones. And you can there's power ratings for each of these versions. It depends the length of the LED and the density of the LED. I will throw up a chart somewhere on the screen which talks about the power requirements, but for my use case I have mostly found that if you go with the basic 5 amps in power input, we can it's mostly suffices for a length of up to around 700 to LEDs, which is pretty long, and I've never had a requirement to have longer than that. So one other thing you can use is this kind of third-party LED controller. So you have got the outputs and the power input, and you can also do a sound input, and this supports controlling the pattern based on sound. These are not cheap, and these are pretty pricey actually, even on Amazon, and you could use it if you are doing a proper commercial kind of setup, let's say. But for our basic automation we are going to use ESP32 board, and we can control everything from Home Assistant. For this video, let's go ahead and see how we can program this WLEDs or addressable LEDs, and how we can integrate them into Home Assistant and get the best out of them using automations in Home Assistant. So for this project we are going to need some accessories. So the most important one is obviously we are going to need the ESP32 board. We need some kind of power injection capability. So we need a 5 ampere power supply like the one here, which is available on Amazon. And since the LED strip comes with these wires, so we need a way to input the power. So for that we can use we can use either this kind of power injection, this kind of power input plugs that are available on Amazon, or something simpler such as this. For this project I'm going to use this one, but just wanted to show that you can use another type as well. And then you're going to need some kind of power cables with a male one on one side and a female on the other side to connect to this I'm going to use to connect to these GPIO pins as a simple solderless connections. And we need the wire strippers. I have these ones, but you can use the one which you have. And finally I have these solderless wire connectors which I'm going to use just for the convenience of this project. But as I mentioned earlier, that if you want to make this permanent, you would probably need to solder the ends, and also you would probably look at using a thicker gauge wires than these. So there are plenty of thick gauge wires available in Amazon, and I do have that as well, and I'm going to show that in one of the later projects when I do this setup with the proper soldering on. But for this one we are going to use a simple wiring setup, and of course you'll need a Phillips head screwdriver to attach some of these wires. And this should be all for you to get this project done. So let's get started. Okay, the first step that we need to do is we need to install WLED software on our ESP32 board. For this let's connect this ESP32 board using its power cable, using a data cable that comes with it. Remember that you need to use your cable which transmits data, and it can't be just a power cable. So here I have plugged it in. Let me bring this in front of the camera. Okay, so here I have plugged it into my computer now with a data cable, and let's go ahead and set up WLED software. So for that, okay, to set up to download and install the WLED software, you need to go to this website, which is installed at wledme.me. I'll leave the link in the description, and here you can choose a version. By default it selects a beta version,
but I would like to select a stable version, so 0.14.4, and then I'm going to hit install. And if your ESP board has been directed correctly, you should see an entry like this. So hit connect, and as you can see, it gives an option for install, so click on install and install. You can do this installation from your ESP home from within Home Assistant as well. However, I find it easier for me to set up the ESP32 board separately through the by connecting it directly to WLED software and then integrating it with Home Assistant as a last step. So let's give it a few minutes for the software to install. So the software has now got installed successfully. Click next to configure the Wi-Fi for this ESP32 board. Once you configure Wi-Fi, you don't need it to connect it except for supplying power. You don't ideally need to connect this from the computer, and you can connect it over Wi-Fi to transmit instructions. This would be especially useful when we use our WLED mobile app to configure and control the LED, which we are going to connect to this power to this ESP board eventually. So let's go ahead and set up the network. So now the Wi-Fi is connected, and we can just click on visit device, and there you go. That's your WLED software, which you can now configure to control this device. However, next step is to connect the LEDs and switch the LED on, and then we are going to control the LED from here. One thing to note though, this entire setup can be done in certain browsers, such as I'm using a Chrome browser or a Firefox browser. You will not be able to do this in some of the unsupported browsers such as Safari. So this is something you need to keep in mind if you're not using Home Assistant to do this configuration. Okay, so let's move on to the next step. Let's do some wiring. Okay, so here is the schematics for my ESP32 board, which is WR00M32. So you see this number 16 is a 3v3, which is a 3.3 volt supply. 17 is a ground, and alternately you can also use the 14. And then this D4 is a number 20. And if you look at the schematics, it does say it supports analog data, which we can use that. So let's go ahead and connect the wires. Right, now I've connected the wires to the ESP32 board. The green wire is going to be the data wire, which is connected to D4, and the white one is going to be my ground wire. I've connected it to ground 14 pin. Next, we are going to look at the wires in the LED strip. Okay, so the red is your power, the white is your ground, which goes with the white on the ESP32 board, and the red will also connect to the power source from the input. I'm going to use this solderless connector to connect the wires together, the ground with the ground, and red with the input. So this I will be using this power injector, and I'll connect the black is the ground on this power injector, so I'm going to connect that along with the other two grounds. So all the grounds need to be connected together. You need to remember that, otherwise your thing will not work. I'll use this multiple connector for the grounds because I have more than two, and then I'm going to connect the power together, the reds together, which are your powers, using your another solderless connector. Yeah, and then finally I'll connect the greens together, and green will function as a data input, so that is the one which will, so I'll use the solderless connector for connecting the green together, and the green is the one which gives instructions to the LED. Right, now I have these two power inputs, the ground and the red is the power and black is the ground. So we need to connect these to the respective, so the ground to the ground, so which is the white from the ESP32 board. So let's connect the grounds together like so, and yeah, let's make sure the connection is tight. Next we need to connect the ground from the LED strip, the power injection, and the ground, both the grounds from the LED strip. Before that, let's clip on the extra wire connector, and now let's splice these two wires. Let me use my splicer to splice open these two wires and get them ready so that I can insert it into the solderless connectors. Let's get them tighten up so that the hairs don't split when I insert them. Yeah, looks good. Okay, so I have these 2 points ready, and I have the ground from here. So let's do the grounds. So we already have 2 grounds, so we need 4. So I can't use this one. I'm going to switch it to a bigger one. So let's use this one. So let's get the ground. Let's get the ground in, and ground number 2. Put in. Then we have the ground number 3. So ground number 3, and then we have the ground number 4, which is this. Yeah, sometimes this can be a bit tight. Yeah, so we have ground number 4 going in here, like so. So now that we have all the grounds in, we need to connect the 2 data together. So let's do that. So let's connect the data together, like so. Yeah, so let's connect the data from the ESP board to the data from the LED. And yeah, so now we have all the 4 grounds together. We have got the 2 data together. The last thing is the power. So the power should go with this power, the one which is going to serve as our input. Yeah, okay. Now let's get all these things aside, and the first thing I'm going to do is I'm going to check if the power is working fine. For that, I'm going to let's first plug this in to the power supply, power source. Yeah, let's see. Yeah, this is on, and let's see if we can power the LED. Yeah, so ideally this should have supplied the power. Okay, so now I've done all the connections. So I've got the 4 data together. So all the 4 data points, all the 4 grounds together. I've got the 2 data together, and attached all the 3 power together. So yeah, I was trying to, initially I wanted to do it with one. I didn't think I would need to connect this power, but it turns out that I need to connect all the 3 power together, which is fine. And yeah, now I will connect the power to this, and last thing is I'm going to connect the power to the ESP32 board. Let's do it, and voila, so you can see the LEDs have been powered. So now let's try and see if we can control it from our WLED software. Okay, so now I'm on the WLED page on my browser, and it's connected to my ESP home device to the IP address. And yeah, we can see that it is displaying the color orange. If we change the solid color to blue, it changes to blue, and it changes to green, it changes to green. So that means we are able to control it from here. So we can hit the effects like bouncing balls, or let's say breathe, yeah, or blink rainbow. And yeah, you can see the effects. Let's do chase. Yeah, you can see the effects are taking place. So that means we're able to control it. I can also control the brightness up and down with this toggle here. Yeah, okay, so definitely we're able to control this from the software. The one thing you might want to do is set up in config, go to LED preferences, and here I have this brightness limiter. I can turn it off. You'll notice that the brightness is increased, and if I apply the limiter and let's say I decrease the current, so if you want to control the current, for example, do that from here. So I have decreased the current and the brightness has decreased as well. Let me do an increase again and hit save, and as you can see the brightness has increased. So that is one thing you might want to change, and depending on the hardware you're using. And the next thing you might want to do is this color order. If you are setting red and it blue, and if it gets set as green, or green is being set in the LED as blue, or red is being not being set correctly, then you might want to come here and change the order and figure out what order works for your LED. Next thing you might want to change is the number of LEDs. This is 450 here. It has auto detected the LEDs on my strip. However, if you feel that it is not detecting correctly, you can increase or decrease the number. For example, if your LED strip has 720 LEDs, then you can update this number to 720. Last thing is the GPIO pin number. As I mentioned earlier, I'm using pin number 4, so the default 4 is correct and I don't need to change. I generally don't need to change any other settings here, so we can click save and exit back from here. The one other thing you might be interested in is the segment. So segment is basically a way to divide your LED strip into multiple parts and then control each part with a different effect. So for example, if I add a segment of say the first 45 LEDs, and let's say we want to define 10 segments, we can do 10 or 45 each because the total LED count is 10. So total LED count is 450. So as you can see immediately, there are two different colors applied to the two segments. So if I just segment 1, if I open this, you can see 0 to 45 is my segment 1, and the rest of the segment is by default goes into segment 0. But I could add one more segment to say 45 to 60, for example, and then we can apply different effects. So for example, if I remove the full LED and then just leave segment 1, and let's say I apply let's say chase effect. So if you see closely, you will see that the chase effect is only happening in segment 1, which is initial 45 LEDs, and the rest of it is holding the color solid. Now if I go to segment 0 and change the color to blue, as you can see the segment 0 has changed to blue without impacting the effect that you have on your segment 1. So this is how you can create and control segments. If you want more details of how to use the WLED software, you can go to the documentation page. I will leave a link in the video description, and you can play around with more settings. So now that we are able to control this LED strip from WLED using the ESP32 board, let's go and integrate this with our Home Assistant instance as the next step. Okay, now I'm on my Home Assistant devices, settings, devices and services. So you can navigate here through settings, devices and services, and as you can see it is automatically detected by WLED because it is on the same network. But if it doesn't detect, you can always use this add integration option and search for WLED and then hit this, and this here you need to get the IP address of your WLED device connected to a ESP32 board, and make sure that it is reachable, either it is within the same network or a sub network to which your Home Assistant has access. Try and give it a static network through a router, static IP address through a router if you don't want to disconnect integration to misbehave. So let's go ahead and type the address and hit submit. Yeah, so it has detected the WLED successfully. I'm just going to give it a area as office finish. So now if we go here, okay, so now we have connected to the device. If you switch on the WLED, you can see that it's switched on, and we can change the effects by using this color palette. As you can see, it's giving some nice effects, yeah, and so on. So yeah, we can definitely control it. The last thing we can do if we want is to create some automation. Let's switch it off. So for that, let's go to devices and services, helpers, and let's create a helper for input. Let's go with a toggle, and let me name it as WLED test, and icon as LED strip. Create. Okay, then let's go to the dashboard. Let's add the entity test as this and continue. Okay, that's fine. Add to dashboard. Let's click done. Okay, now let's set up two automations. So for on, let me LED test. Let's say so on. Okay, where is it? Okay, let me try this again. So let's say LED test. Okay, put boolean WLED test to on. Then we are going to turn on our LED and change the color palette option to fire. Okay, and then we have the WLED off. Sorry, let's go to WLED off. Let's select the WLED test input boolean, and let's select the option as off. For this, I'm going to just simply change the color palette option to ocean. Yeah, and I'm not switching it off. So let's see this in effect. So my dashboard, I'm going to switch this on. Okay, it's switched on, and it is showing the fire pattern, and if I switch it off, it's switched to ocean pattern. Let's try this again. Switch to fire pattern, and I'm switching it off. Switch to ocean pattern. Yeah, and as that's how a simple automation works. Obviously you can create a way more complex automation if you want.
So I hope you enjoyed this video. I'm a big fan of these addressable LEDs, and I do have them all around house. In fact, I'm about to do a small project in my library where I'm going to put some lighting for my library cabinet, and I also have a plan for a bigger project which will be my highlight wall, LED highlight wall. If you are interested in such projects, do let me know with a comment in the comment section, and I would be happy to shoot them for you in case it's something you guys are interested in. If you enjoyed this video, do not forget to hit the like button and share this video, and if you want more such videos to pop up on your YouTube, then definitely do not forget to subscribe. So I will see you in the next video. Till then, stay safe and stay connected.